Hello and good afternoon. CTS231 section 875 students for the fall 2016 semester at Anne Arundel Community College. This is the CCNA 4 course, or the Connecting Networks course, and today's video tutorial is going to be on Skills Integration Challenge 5412, so Packet Tracer Activity 5.4.1.2, and this is a pretty hefty exercise here. Got a lot of heavy lifting. This is going to sort of pull together everything that we've learned in the course up to this point, and we're going to be focusing a lot as well, as you can see as we scroll down here, on configuring NAT, OSPF, all kinds of things. So let's go ahead and dive in here. So we're going to start with the documentation, basically asking us to fill in the information for the network. And so we're going to go ahead and start here at the implement the following requirements in your documentation. So configure remote management access, including IP addressing and SSH. And this is on the HQ switch. So here's the HQ router. So we're going to jump onto the HQ switch. Let's pull that down over here. And we'll stretch it out a little bit. And let's also, under the options here, let's go to the font and we'll pull that to a 20. There we go. All right, so let's bring that switch back up. There we go. Much larger font, a little easier to see. All right, so here we are in the HQ switch, right? So let's go from user exec into privilege exec, and let's get into global config. And it's asking us to set the domain name to cisco.com. So IP domain name, and it's going to be cisco.com. And if you follow along, if you look in the lower right-hand corner here, interesting, the activity starts out with you getting a point or already having a point assigned. So we just picked up an additional point there for the domain name. So the user admin with password let me in. So again, configure a username, and we're going to go case sensitive like they show here. Now, we could say password, but my guess is they're looking for a secret to be configured. So, and we'll know right away from the completion percentage if we gave them what they were looking for. I don't see a point there, so let's do this. It's possible that they could have been looking for username admin password let me in. And let's see if that's what they, and that's what they were looking for. So I highly recommend against using password because it's just simply going to give you a type 7 password if you did the service password encryption command, whereas you're going to have an MD5 hash, which is a little more difficult to crack than simply the type 7 password. So, but want to make sure that we're giving them what they're looking for here. So user admin password let me in. We're going to do a crypto key length. Now, before I can simply run in here and say crypto key, we need to make sure we've got the domain name, and that's already been done. So now we'll go ahead and we'll say crypto key generate RSA. And what's the modulus going to be? They want 1024. So there we go. We create a key with a modulus of 1024. Now we want to use SSH version 2. So IP SSH, and I'll do a question mark here, and you can see we've got authentication retries, timeout value. Well, we're looking for version number, right? So IP SSH version 2. And we're going to limit it to 2 authentication attempts and a 60-second timeout. So IP SSH authentication retry, so number of retries, we said it would be 2. And then a 60-second timeout. So IP SSH timeout, and this is going to be the timeout interval if they don't enter their password incorrectly 2 times. So we've got a 60-second timeout there. So clear text password should be encrypted. So what are they talking about there? Well, if I say show run, and maybe this is why they wanted us to do the type 7 clear text instead of doing a MD5 hash. See, we have username admin privilege 1, password 0, let me in. Well, there is the password in plain text. So we're going to go ahead and say service password encryption, and we hit enter. And so now when I say do show run, we end up with a Vignere cipher. Hope I'm pronouncing that right, which is very, very easy to crack. In fact, if you were to cut and paste this and literally Google crack Cisco Type 7 password, you'll find about 100 sites that'll let you paste that in and tell you what the password is. So definitely the hash is better, but they're looking for the type 7 password here. Okay. And this would also, if we had passwords on the VTY or the console lines, that would also encrypt those as well. All right, we're going to configure, name, and assign VLANs. Ports should be manually configured as access ports. So let's scoot up a little bit here. We're going to slide this to the top. And I'm assuming that this is what they're looking for. Let me make sure I'm reading this correctly here. So the HQ switch should be VLAN 15 and VLAN 30. And then the private address is the 10.10.10.0/24. All right, let's come back over here. Let me make sure I'm reading this correctly. So VLAN 50, VLAN 30, 45, and then management is going to be 60. Oops, let's shrink that down. All right, so let's go ahead here. My mouse is not cooperating here. And that is not what I'm trying to do. There we go. All right, so if I was to say do show VLAN brief, let's see what we see here. Let's make this a little larger. All right, so right now we've got VLAN 1 and that is it. So we're going to go ahead and create some VLANs here. So we're going to say VLAN 15. And the name is going to be servers. And then we're going to say VLAN 30. And the name is going to be PCs. And then we're going to say VLAN 45. Name is going to be native. And then VLAN 60. And the name is going to be management. All right, so we've created all of our VLANs. Now let's go ahead. It looks like we've got some interfaces we're going to put into these different ranges. So we're going to say, or in these different VLANs. So interface range, FA011 to 20. And we're going to say switch port mode access, switch port access VLAN 15. And then we'll no shut those ports. And then we're going to say interface range FA01 to 10. And we're going to say switch port mode access, switch port access VLAN 30. And then let's go with interface gig 01. And this is going to be a trunk link. So we're going to say do show run. Let's see what gig 01 has on there right now. All right, nothing on gig 01. And if I drag this to the side, that's probably gig 01 right there. In fact, let's get into interface gig 01 and say no shut. So gig 01, show IP interface brief. Gig 01 is down. So fast Ethernet 01 and 011 are the only ones that are up right now. So let's see if interface fast Ethernet 01. No, that's not it either. All right, so I'm kind of curious as to the interface that's there, and I probably looked right by it over here. All right, so we've got on the HQ switch, it shows VLAN 60. Okay, so we'll stick with gig 01 here. So interface gig 01, we're going to say switch port mode trunk, switch port trunk native VLAN 45. Left out the VLAN keyword there, native VLAN 45. And let's go ahead and say write mem. So my guess is that it's disabled on the HQ router side. So let's take a look at the HQ router here real quick. And let's see what we've got in terms of show IP interface brief. And that is probably, I'm wondering if they're going to let us do the router on a stick configuration maybe here. Yeah, so let's go into global config interface gig 0. Yeah, so they've got some sub interfaces we're going to have to configure here. So gig 00, and we're going to say no shut. And that should bring that interface up. And there we go. Yeah, so we're going to be doing router on a stick, it looks like. So let me slide this up a little bit here. Okay. All right, let's kind of stay on target. So configure name and assign VLANs. Ports should be manually configured as access ports. We did that. And then VLAN 60 for the management. So let's get the switch back up, and let's not forget that. So pull the switch back up and say interface VLAN 60. Get the global config first. Interface VLAN 60. IP address is going to be 10.10.10.146. And that should be a /24. And it is. All right, so that interface is up. Access ports, configure trunking. So we did that on the switch. We're good there. So now let's go ahead and take care of what we see over here, which are going to be these sub-interfaces, one for each of the VLANs. So we're basically doing router on a stick, right, for our inter-VLAN routing configuration. So on the HQ router, we're going to go to gigabit 00.15. Now remember, there's an order of operations here. If I say IP address 10.10.10.161, and say 255.254 and hit enter, we're going to get an error message telling us that, hey, you're doing a sub-interface. So if you're doing a sub-interface, I need that 802.1q information, all right, that incap.1q. What VLAN tag is traffic going to be showing up with in order to get into this sub-interface, gig 00.15. So I'll say incap.1q15, and then we'll put the IP address on here. So then interface gigabit 00.30, and that's going to be incap.1q30, and then the IP address will be 10.10.10.193. And again, they're giving us a subnet mask, right? So it's pretty nice that the subnet mask is right there, 255.192. All right, and then interface gig 00.45. And this is going to be incap.1q45 and the IP address of 10.10.10.145. And that's a 240 subnet mask. And then finally, int gig 00.60. All right, incap.1q60. And then IP address 10.10.10.145. And this is going to be 255, 255, 255, 240. And so we should go back to the switch, actually. And let's pull that off. Interface VLAN 60. No IP address, 10.10.10.146. Huh. Let's take a look here on the switch real quick. Yeah, so there's a MAC address. Let me do this. We're going to say no interface VLAN 60. There we go. So interface VLAN 60. So we had to wipe the whole VLAN out there. IP address 10.10.10.146. And this is actually a 240. That is correct. All right, so no shut. Let's see. Can we ping 10.10.10.145? Do we have reachability up to that sub-interface yet? Not yet. All right. So do show IP interface brief. Let's take a look at what we've got here. So we've got a whole host of sub-interfaces hanging off of gig 00. And we need that IP address, actually, it looks like, assigned to IP address 10.10.10.145, 255, 255, 255, 240. Did I put the wrong IP on there? 10.10.10.145. All right, let's do this here. I see what I did. Okay. So I accidentally jumped down. Let's get an interface gig 00.45. So I put the wrong IP here. IP address should have been 10.10.10.129. Actually skipped it there. And then interface gig 00.60 should be, pull this back up, 145. So there we go. And this also explains, excuse me, why we were unable to ping, I believe. There we go. So now we've got reachability. Okay. So where are we at right now? Well, we did the trunking. We got all the VLANs on the ports. Let's implement some port security. So on FA01, interface FA01, we're going to go ahead and allow 2 MAC addresses. Now remember, before we do anything with port security, I need to say switch port security by itself and hit enter. And that indicates that I want port security to be enabled on this port. Now I can get into switch port security, allow 2 MAC addresses that are automatically added to the configuration file when detected. Well, MAC address sticky is going to be automatically added to the config file, right, and automatically learn. And then switch port security maximum is going to be 2, so we're going to allow 2. The port should not be disabled, but a syslog message should be captured if a violation occurs. Now that's going to be restrict, but let's take a look at switch port security violation. You've got protect, restrict, and shut down. And the difference between protect and restrict is that restrict will not disable the port, but it will generate a syslog message. And protect will not disable the port, but it will not send a syslog message. So we want to go with restrict. Now, if it was shut down, that would just straight up shut the port down. And so that was for FA01. Is that correct? It is. So now disable all other unused ports. Well, do show IP interface brief. All right, so all other unused ports is literally going to be everything except 1, 11, and gig 01. So interface range FA0/2 -10 to FA0/12 to 24 and gig 02. Is that right? 24 gig 02. And I can't run that from there. That should have... Oh, I'm sorry. I've got the... There we go. All right. So then we're going to shut all of those ports down, right? That's every port that's not being used. Do show IP interface brief. So the only ports that we have up are 1, 11, and gig 01. And if we come back here to the diagram, you can see on the switch only 3 ports are being used. So there's gig 01, and if I mouse over, we should get it. Sometimes this mousing over works and sometimes it doesn't. But you can see that we've got, that's either FA11 or FA01. I could look at the VLAN match up there to see, but again, just those 3 ports being used. Everybody else is shut down. And now we're on to HQ. So configure inter-VLAN routing. Done. We already did that, right? That was where we did those sub interfaces here on do show IP interface brief. All those sub interfaces, that is our inter-VLAN routing scheme. So configure DHCP services for VLAN 30. Use LAN as the case-sensitive name for the pool. All right, now what's interesting here is it doesn't say that we should exclude any addresses. It just says configure DHCP services for VLAN 30. So to do that, we're simply going to say IP DHCP pool, and then the name of our pool is going to be LAN. And then what do we have here? Well, we've got the default router. Now remember, this is VLAN 30, which the staff PC falls into. So that would mean that the default gateway address is going to be this 10.10.10.193. So what we're going to say is the default router is going to be 10.10.10.193. We're going to say, well, actually, there is no DNS server. There's a file server, and let's make sure here. Yeah, I see a web server, no DNS. So DNS is not going to be configured. But what about our network? Well, the network is 10.10.10.192, but now we need a subnet mask. And again, if we were to step over here, you could see that there's the address, but the subnet mask is also 255.255.192. All right, so that takes care of the network setting and then the default router. And that's really all we've got. We're not setting any options, right? No options are being configured. So if I were to come over to the staff PC here and come to the desktop and come to IP configuration, let's flip it to DHCP and I should get 194. Oh, look at that. Perfect. So we get the 10.10.10.194 working brilliantly, right? So, whoops, we'll go back over here to the desktop. And let's close that out and come to the command prompt. And so can I ping? Let's try to ping. Well, actually, we're not going to get beyond the HQ router right now, so that's okay, though. So can I ping 193? I can, because that's that default gateway address. So we're good there. Okay, so where are we at now? Let's squeeze this router in a little bit here so we can see what's going on. All right, so we're going to implement routing. So use OSPF process ID 1 and router ID 1111. And this is on the HQ router, right? So very straightforward here. And this is all sort of the routing and switching essentials material, really. Nothing too advanced here. So we're going to basically say IP OSPF 1. Whoops, sorry, not IP OSPF, router OSPF 1. And we're going to say the router ID is going to be 1.1.1.1. We're going to configure a single network statement, right? So network 10.10.10.0. Now remember, wildcard mask, not the subnet mask. And we are in area 0. Does it say area 0 there? It doesn't, but it's probably, we'll see here. We should, yeah, there we go. We get the neighbors coming up, right? So we've got a neighbor router 2, neighbor router 3. Disable interfaces that should not send OSPF messages. So we're going to say passive interface default and then no passive interface serial 000. So we're going to see that full to, or loading to full here in a second for both neighbor 2222 and 3333. So we'll wait for neighbor 3333 to pop up and then configure a default route to the internet. Well, let's see. What do we have configured so far? So if I were to say do show IP route, do we have a gateway of last resort? We do not. So let's take a look here. The HQ router, this is clearly going to be the gateway of last resort, is this network segment here. So this 209, which is on serial 010. So do show IP interface brief. And serial 010, it should be 138, which means, if it's 136, so 137, let me go ahead and try to ping 209.165.202.137. And do we have reachability to that address? And let me make sure I read that right. It's 136.202.136/30. So it's going to be 36, 37, and 38. So we should be able to ping, unless I typoed something, 209.165.202.138. And that interface is up. Huh. And it's interesting that I can't ping my own address, and there's got to be something simple that I'm looking right past here. All right, so let's say do show run. Let me double check this here. So yeah, I am 138. 209.165.202.138. And I can't ping my own address. It's possible, yeah, it's possible that maybe Packet Tracer just has this locked down so that we can't ping it. But here's what I would say is IP route. Now remember, we need to do a default route. We'll do the quad zeros. And I'm going to do the outgoing interface, serial 010. So we're at 54, and we'll see if this is what is going to be acceptable for Packet Tracer. Yeah, we get 2 points there, so we're good. So now all I need to do is get back into my router OSPF 1 and say default information originate. And what that's going to do is that's going to go ahead and advertise a default route out to can't get to branch 1. Branch 2 is locked, so I can't check on these guys. But it is over here on branch 1 and branch 2 where they would pick up that default route. All right, so we've got one network statement. We've got the disable the interfaces with the passive interface default, and then no passive on the serial. That is what I did. I'm missing. Did I do? I think I left one out. Do show run, and let me see here the OSPF. I think I left one interface disabled. Yeah, no passive interface serial 000. Do show IP interface brief. And it should also be serial 001. No passive interface serial 001. All right, so those two interfaces. Oh, and you know what? They're also going to want... Yeah, so that's why the neighbor 3 didn't pop up. And so then they're also going to want no passive interface gig 00.15. Well, actually, that's fine. No, because we're not running. It'll be interesting to see. So we're not running OSPF out here, right? So it's okay that we passive all of those sub interfaces, but it'll be interesting to see if Packet Tracer is okay with that, or if Packet Tracer is going to be looking for us to actually say no passive interface on each of those sub interfaces. So, but we've got our neighbor adjacencies up here, so we're good there. Now we're going to come down to implementing NAT. Well, remember this HQ router, right? This is our headquarters router out to the internet. So branch 1 and branch 2 over here, the only way out to the internet that they have right now is through the HQ router. And again, remember that earlier we said that, think of branch 2 as maybe New York, branch 1 could be Dallas, Texas, and then our headquarters is in San Francisco. And so they've got WAN circuit connectivity that brings them into the HQ router, and then they can get out to the internet. So we're going to implement NAT. So configure one standard, one statement ACL number 1. All IP addresses belonging to the 10.10.10.0/24 are allowed. Right? So this is easy for us coming off of all this NAT work that we just did. So we're simply going to say access list 1 permit 10.10.10.0 0.0.0.255. And that's it. That is the ACL. And now refer to your documentation and configure static NAT for the file server. Well, again, static NAT, very, very straightforward out of all the different types of NAT. Let's see if I can avoid having that thing blow up again. So there's my file server on VLAN 15. So again, it would be IP, NAT, source, IPNAT inside. Sorry, I always get inside and source mixed up. IPNAT inside source static, and we're simply going to say that the inside address of 10.10.10.162 corresponds to which inside global address? Well, it would be that 198.133.219.130. And that's it. That is your static NAT statement. So let's take a peek over here real quick. All right, refer to your documentation, configure static NAT for the file server, configure dynamic NAT with PAT. So in other words, NAT overload or port address translation using a pool, and we can name the pool anything we want, a /30 mask, and use these two public IPs, which would be 128 and 129. All right, so first things first, the ACL is done. Let's go ahead and create the pool. Now we can name the pool anything, so we'll just say we'll call it PAT. So IP NAT pool PAT, my starting address, which I now need to slide this back over this way. Let's shrink this a little bit here, is going to be, where was the rest of that command? All right, IP NAT pool PAT. So my start address is going to be a 198.133.219.128, and the ending address is going to be the same address, 198.133.219 plus 1, so 129, because we're using those two IP addresses. So what is the network mask? Well, what's interesting is in the previous activity, if you remember in Packet Tracer, I think it was 5236, it ended up having us put the entire /30 in there, right? Where we had the network ID along with the broadcast address in the definition. Because when we put the net mask down and we say it's a /30, there are only certain values that it can be. So here, we're going to be able to get away with saying 198, 133, 219, 128, and 129. But what is interesting is that would have to be 255, 255, 255, 252. And let's see if we actually get any credit for that. Yeah, let's see, a /30 and these two public addresses. So let's go ahead and say IPNAT pool, or not IPNAT pool, IPNAT, I keep forgetting, inside source list. Our ACL is 1, and we're going to tie it to our pool that we simply called PAT. And remember, we are overloading because we are doing port address translation. However, configure dynamic NAT with PAT using a pool name of your choice, a /30 mask, and these two public IPs. Okay, so 128 and 129. I'm still not confident that that statement there is actually correct. So let's go Control U. So we'll move on here and let's see what ends up happening. So verify staff has received full addressing from HQ. So where is staff? Yeah, so we already looked at staff and we saw that it's got the full IP addressing from HQ. Oh, and before I forget, let's make sure we get the interfaces properly labeled IPNAT inside, IPNAT outside. So do show IP interface brief. And we've got interface serial 000, IPNAT inside, interface serial 001, IPNAT inside, because those are my private RFC 1918 networks. And then interface serial 010, IPNAT outside. And we need to get into, and I'm wondering if we have to get into each sub-interface here. So IP gig 00.15, IPNAT inside. And interface gig 00.45. Oh, sorry, 45. We're here. We'll do it. I was going to do 30. IPNAT inside gig 00.30. IPNAT inside. And for 45, actually, we don't need that because that is actually the native VLAN. So let's get back into gig 00.45. No IPNAT inside. All right, and then 60 is the same thing. I think 60 is the management VLAN, so we'll set it up anyway. Interface gig 00.60 because maybe this needs to get out to the internet. IPNAT inside. The native VLAN definitely does not. All right, so we've got that set up. Do show run. All right, so right now we are 66 out of 70. Let's make sure they didn't want gig 00.45. There's really no reason. IPNAT inside. Do show run. Let's take one more look here. All right, so we've got that set up. NAT inside, NAT outside. And we've got our router ID. So let's go ahead. And it looks like we're missing 4 points. So my guess is that they want us to say router OSPF 1 no passive interface. Oops, sorry. No passive interface gig 00.15. Let's see if that's what they're after here. And I don't believe it is. .30. .45. Oh, in fact, if you notice, we're losing points for putting this on here. So yeah, they definitely don't want that. So let's go ahead and say passive interface gig 00.15, passive interface gig 00, passive interface gig 00.30. All right, so we're 4 points away. We've validated everything here. So now let's see here. All devices should now be able to ping all other devices. If not, troubleshoot and isolate the problem. A few tests include remote access from the switch by using SSH from a PC. Okay, so let's try to SSH over here. Whoops, not what I wanted. Back to the desktop. And we've got the command prompt. And the management IP was 10.10.1 or 10.10.10.146. Invalid command. I'm trying to remember. Whoops. I'm trying to remember the SSH command. SSH, and what is it looking for there? Yeah, I am drawing a total blank here. I can't remember what they want. And maybe it's the, well, it wouldn't be the -L. Maybe it is. Let's try that. 10.10.10.146. All right, connection timed out. So let's see. From the PC, can we ping to 10.10.10.146? So we're trying to ping the HQ switch. Now, the request is timing out. So we're trying to ping the management VLAN, VLAN 60. So what do you think the problem might be? And this is always one of the trickier things that they sometimes will catch you on. Let's take a look at HQ switch. Now remember, this is management plane traffic, right? This is not data plane traffic that's passing through the switch. This is traffic destined to the switch. So if I were to say show run, we're looking specifically for a command. It's usually down after the interfaces. Yeah, and I don't see it, and I guarantee we need to have it in here. So this is always one of the trickier things with the switches, right? Is this is traffic destined to the switch. And when I say ping 10.10.10. What's one of the PC IPs over here? Branch 2, they don't give you the PC IPs. Let's see, desktop. So 10.10.10.10, that's a good one. So we'll just ping all 10s. And you can see that I'm trying to ping out, but it's not working. Well, if we go to the HQ router, let's see. Do I have a route for the all 10s? Do show IP route OSPF. And I certainly do, right? So there is a route for those 10 networks. So the question is, why don't I have reachability? Well, remember, the switch, just like a node, a PC, or a node on the network, needs a default gateway. So IP default gateway, and what is the default gateway of VLAN 60? Well, remember, it's going to be that IP address that we have here. Do show IP interface brief. It's going to be that 145 IP. That is the default gateway for the switch. Because again, the switch needs to have a default, and look, you even got a point for that as well. So now when we say do ping the quad 10s, let's see if maybe it's ARPing out, and now we have success, right? So now it's doing what it's supposed to do. All right, now let me check here. Remote management. So we did the remote management, but now let's come back and let's see if I try to get there now, right? We can ping. Now it is working. Can I SSH? Absolutely. Let me in. I think I just typoed that. Hold on. Let me in. Try to SSH. The password is LETMIMEIN. Let me in. Yeah, it's not taking my password, but that is definitely the password I entered, and we are able to at least connect. The SSH version is there. We've got the VLANs. The outside host should be able to access the file server at the public address. All right, so can we get to the web servers? Let's go to Sales 2, and let's get back to the desktop here. Let's pull up the web browser, and let's type in 64 100.150.10. All right, welcome to the web server. So we can go from the inside out. Can I go from the outside in? And it's a file server, so we should be able to ping that file server. Ping 198.133.219.130. And let's see if I've got reachability from the outside in. And take a look at that. So now if we hustle over here and say, do show IP Nat Statistics, you can see that we've got our Nat Statistics are set up there. What about do show IP Nat Translations? And there we go. You see the ICMP packets from the inside global coming to the inside local. And then we also see the connection here, this HTTP connection from PC2 out to the web server. Now, we're still at 67 points, so let's go ahead and let's take a look and see what they've dinged us for. Oh, I forgot the native keyword. And the VTY lines. Okay, I don't remember seeing those VTY lines listed, but let's knock that out. So, first things first, remember when we set up the do show run, we set up the interfaces here, and VLAN 45 was the native. So what I forgot to say was interface gig 00.45, and then it was supposed to be incap.1q45 native. And so then that would have given us an additional point, putting us at 68. And so then the VTY lines, and I'm wondering, I must have read right by that. I didn't see those VTY lines on there, and I can't remember if it was the switch. On the switch. Clear text password maker. And so actually, this is why we're unable to connect as well. So let's jump onto the switch. I think we're done with the router. So we get onto the switch here. And we're going to say line VTY 0 to 15. And we're basically going to say login local and transport input SSH, transport output SSH. We'll do it both input and output. And there we go. So that rounded us out to 70. And now that makes sense as to why when I was trying to SSH to it, we connected up, but it wouldn't allow me to log in, LETMEIN. And I just figured I had fat-fingered the password, but that is not the case. So there we go. Now we are on the HQ switch. I can't get into enable mode, right? Because we never set the enable password. So what commands do I have access to? Probably not a whole lot. So we'll say show version, and there we go. All right. Well, this is going to wrap up Packet Tracer Activity 5412, the Skills Integration Challenge for Chapter 5. If you have any questions, please feel free to email me. And if not, have a great week, and I will see you guys soon.